The purpose of this video is to give a simplified explanation of how horizontal and vertical diaphragms work as structural components in residential construction. This first diagram is used to show how a horizontal diaphragm, such as a floor, connects to a vertical diaphragm, transferring load to the foundation, which is the goal of the structural elements. When you have a height to width ratio creating a tall structural element, the forces can easily tip an element like this over. When the height to width ratio provides for a wider than tall component, it's much more difficult to tip over. If you think of a tall glass sitting on a table, very easy to tip over. A bowl full of water, more difficult to tip over. When you have a structural element in a residential cross section, this is a cross section of a residential structural element. You have a lower floor, double top plates, what we call a rim joist, the upper floor, studs, bottom plate, and floor diaphragm. It's the horizontal diaphragm and the vertical diaphragm that we're going to focus most of our attention on. The horizontal diaphragm or floor framing system consists of the shear panel, the plywood, in this case 3/4 inch plywood or OSB, which is connected to floor joists, in this case 2x12s at 16 inches on center. While the plywood creates the diaphragm, providing the ability to transfer the load to the walls, it is necessary to connect this diaphragm to a structural element to keep it rigid. The plywood in and of itself is not capable of transferring load across a large area, whether this area be 200 square feet or 2,000 square feet. 3/4 inch plywood in and of itself is not capable of transferring the load. Properly connected to the framing members below enables it to transfer the load to the walls. During seismic activity or a wind load condition, once the structure is put under load, a wind load or seismic activity could have forces generating side to side perpendicular, perfectly perpendicular to the structure, or could in fact hit the structure in a manner to create a racking or torquing kind of a condition. Regardless, the loads are transferred in the same manner to the walls and then to the ground. As this component, the floor diaphragm, again, to assemble this component, it's necessary to nail the plywood elements to the floor framing system. You have what we refer to as field nailing. That's nails that occur out in the middle of each individual piece of plywood, 4x8 pieces of plywood. And then you have the edge nailing. It's actually the edge nailing that is critical in terms of stitching the system together. So each of these pieces of plywood would have nailing down this edge in addition to the field nailing, but it's the edge nailing that is the most critical. And this field nailing in a condition like this typically would be 12 inches on center. Edge nailing would be at most 6 inches on center, and sometimes it would be called out to be less. And many times in the wall system, the shear wall, it is called out to be less than 6, and we'll discuss that in a minute. So by having this system nailed together to the common element below, you create a continuous diaphragm that acts as one. Now we have the exterior vertical diaphragm that operates in a similar form as the horizontal diaphragm and has similar components. Many times these vertical diaphragms are referred to as shear walls. These are shear walls. These lines representing, we have created a transparent area here so that you can see the framing members behind. And these are the lines of the plywood sheathing on the exterior. Typically an exterior plywood is 3/8 or 1/2 inch unless it's called out to be greater. The nailing on these shear walls, again, the field nailing, the nails that would connect this plywood to this stud behind, is typically 12 inches on center. The edge nailing is typically a maximum of 6 inches on center. It's very common to find 4 inches on center and even 3 and even 2 inches on center, depending on the loads that the shear wall has to handle. A large narrow shear wall would have to typically have spacing much closer than a wider and not so tall shear wall. All of this again is to carry the forces that have been put into the floor diaphragm over to the wall and then carried down to the foundation and secured by any number of systems to the foundation, again depending on the intensity of the load for that particular shear wall. Once again, it is the edge nailing that is critical to creating a continuous diaphragm for handling the loads. The most important condition in the connection to connect a horizontal diaphragm to a vertical diaphragm is the edge nailing of the plywood that is at the edge of the diaphragm, and that typically occurs underneath plates and studs above it. It is this nailing which transfers this load to the wall, which then is able to get the load to the ground, which is what protects the integrity of the structure. When you have a compromised condition, the forces can deteriorate. The shear nailing actually consists of nails that are different than a typical framing nail. A typical framing nail that are used throughout the framing of a typical home has a specific diameter, and the shear nails are significantly thicker than standard framing nails in that they have to carry this force. So when you have a compromised condition, there's two other components to there's two components to how these nails work. Number one, they themselves must be able to withstand the force, and that's why they are thicker nails, so that they do not shear themselves. And the wood that they are nailed into or nailed through must have structural integrity. If you lose the integrity of this framing element or this framing element, the plywood, then you lose the capacity for the forces to be transferred through the nails into the adjacent system. So in summary, the floor diaphragm, in the event of seismic activity or even wind loads, transfers all the forces that are upon the house to the exterior wall in this condition, down the wall to the foundation, and it does so through the plywood, into the nails, through the nails, into the exterior wall system.